Hi students, today discuss the work done by force and moment of torque. The first one already discussed work done by force. Work done by force is W equal to F vector dot D vector, where F is the force and D vector is displacement. Where D vector is the displacement is A to B, that is the displacement A to B. The position vectors of AB is OB minus OA vector is D vector. Now, work done by force based on exercise problem in question number 12. Forces of magnitudes 5 root 2 and 10 root 2 units acting in the directions 3i vector plus 4j vector plus 5k vector and 10i vector plus 6j vector minus 8k vector respectively. Act on a particle which is displaced from the point with the position vector 4i vector minus 3j vector minus 2k vector to the point with the position vector 6i plus j minus 3k vector. Find the work done by forces. Given forces magnitudes 5 root 2 and 10 root 2 units acting in the direction of the forces. Given the forces acting on the magnitude 5 root 2, the acting on a force is 3i plus 4j plus 5k vector. The next one, the magnitude 10 root 2 acting on the force is 10i vector plus 6j vector minus 8k vector. Given the two forces of magnitudes, one of the forces 5 root 2 magnitude 5 root 2 3i plus 4j plus 5k vector, that is the one of the force, and the second magnitude is 10 root 2, the second force is 10i vector plus 6j minus 8k vector, that is a force. And the force act on a particle which is displaced from the point, one of the point is, that is a OA. That is the point OA is 4i vector minus 3j vector minus 2k vector is the one of the point. And another one point is the position vector, another point 6i plus j minus 3k, that is another point. That is OA, that is the point is OB. Now find the displacement D vector is OB minus OA. Now find the total, find the work done by forces. Total work done. Given the magnitude is given, you know the vector having magnitude, the vector having magnitude lambda along the direction of the vector, that is a vector, that is a force is, that is a magnitude is, that is a lambda, where lambda is 5 root 2. Along the direction of the vector is a vector, that is a vector is 3a plus 4j plus 5k vector. That is the direction of the vector a vector is lambda of a vector by modulus of a vector. The first one magnitude and one of the forces given using the formula lambda into a vector by modulus of a vector. The vector having magnitude along the direction of the vector a vector is lambda of a vector by modulus of a vector. The next one unit is the magnitude 10 root 2. That is the magnitude is lambda 10 root 2. Along the direction of the vector is b vector, that is a b vector. This is lambda of b vector by modulus of b vector. Given the one of the forces, that is F1 equal to lambda, where lambda is 5 root 2. 5 root 2 a vector is 3i plus 4j plus 5k divided by modulus of 3i plus 4j plus 5k. That is one of the force. And the second force F2 is lambda means, that is a magnitude 10 root 2 into b vector. B vector by modulus of b. B vector is 10i plus 6j minus 8k divided by modulus of 10i plus 6j minus 8k. Now first write in the first force F1 vector equal to, given the magnitude is, the first one is 5 root 2 into a vector is 3i vector plus 4j vector plus 5k vector by modulus of a vector is square root of square the value. That is the modulus of 3i plus 4j plus 5k is square root of square the values. 3 square is 3 square is 9 plus 4 square is 16 plus 5 square is 25. That is the force F1. This F1 equal to the force F1 equal 5 root 2 into 3i vector plus 4j vector plus 5k vector divide by square root of 9 plus 16. 9 plus 16 is 25. 25 plus 25, 50. Root 50. That is the value is root 50. Is equal 5 root 2 into 3i vector plus 4j vector plus 5k vector divide by root 50. Root 50 is 25 into 2. 25 root of 25 is 5. Now we can write in the root 50 is 5 root 2. This 5 root 2. This 5 root 2, 5 roots are cancelled. F1 vector is, that is the first force is 3i vector plus 4j vector plus 5k vector is the force F1. Find that force F1. Next, find the force 2. F2 is, given the magnitude is 10 root 2. Given 10i plus 6j minus 8k is b vector. That is F2 vector equal to, that is the second force, lambda of b vector by modulus of b vector. This force is b vector. This b vector equal to 10i plus 6j minus 8k vector is b vector. Now substitute the value where lambda is the magnitude 10 root 2. 10 root 2 into b vector is 10i plus 6j vector minus 8k vector divide by modulus of b is square root of square the values. Square root of square the values 10 square is 100 plus 6 square is 36 plus next one 8 square is 64. 8 square is 64. That is equal 10 root 2 into 10i vector plus 6j vector minus 8k vector divide by root of 100 plus 36 plus 64. 64 plus 36 is 100. 100 plus 100 is 200. Root of 200. Root of 200 is 100 into 2. Now expand that. 200 is 100 into 2. 100, the root of 100 is 10. That is the answer is 10 root 2. That is equal F2 vector equal to 10 root 2 into 10i vector plus 6j vector minus 8k vector divide by 10 root 2. This is equal to 10 root 2. 10 root 2, 10 root 2 gets cancelled, getting the F2 vector equal to 10i vector plus 6j vector minus 8k vector, that is F2. Getting the two forces. Getting the two forces F1 and F2. Now find the resultant force. The resultant force is adding the two forces. The resultant force is F vector equal to F1 vector plus F2 vector. F1 plus F2. Adding the two vectors, F1 already find the F1 is 3i plus 4j plus 5k. 3i plus 4j vector plus 5k vector plus F2 is 10i vector plus 6j vector minus 8k vector. Adding the two forces, 3 plus 10, 13. 13i vector. Next one, 4 plus 6, 10j vector. 5 minus 8. 5 minus 8 is minus 3. Minus 3k vector. That is the resultant force is F vector equal to 13i vector plus 10j vector minus 3k vector is getting the resultant force. Next, the force acting on a point, the position vectors of A and B is, the position vectors of A and B is, the first one position vector is 4i minus 3j minus 2k vector, that is a point A. The position vector is OA vector. OA vector is this one point. 4i minus 3j minus 2k is the point OA. Next, the moving the point is B, where moving the point B is, that is the position vectors of B is OB vector. OB vector is 6i plus j minus 3k. That is the point OA and OB. Given the point OA is OA vector. OA vector equal to, first one OA vector is 4i minus 3j minus 2k vector is OA vector, and OB vector equal to, OB vector is 6i vector plus j vector minus 3k vector is OB vector. OA and OB be the position vectors. Now find the displacement D vector is D vector equal to, now find the displacement D vector equal to OB minus OA. OB vector minus OA vector. OB minus OA. That is the displacement of D vector is AB vector. AB vector is OB minus OA, the position vectors. OB minus OA. OB minus OA. 6i minus 4i. 2i vector. 2i vector. Next one. 1 minus half minus plus. 1 plus 3. 1 plus 3 is 4j vector. Next one. Minus 3 minus half minus plus 2. Minus 3 plus 2 minus 1. Minus 1 and k vector is k vector. That is a D vector. Is a D vector. Now define the force and displacement. Now find the work done by force. Work done by force is W equal to F vector dot D vector. Now find the work down. The work down equal to W equal to F vector dot D vector is the work done by force. Already find the force is F equal to 13i vector plus 10j vector minus 3k vector. That is a force dot D vector is displacement is 2i vector plus 4j vector minus k vector is D vector. Now scalar multiplication of two vectors. Scalar multiplication already know. I dot I value 1, j dot j value 1, k dot k value 1. Now multiply 13 into 2. 13 into 2 is 26. 13 into 2, 26. Next 10 into 4 is 40 plus 40. Next one, minus into minus is plus 3 into 1 is 3. 26 plus 40, 66 plus 3, 69. 69, that is the work done equal to, work done is W equal to 69 units. The total work done by force is W equal to 69 units. Now discuss moment or torque. What is the torque? If a force F vector applied on a particle at a point with the position vector R vector. A force applied a particle at a point with the position vector R vector. Then the torque or moment on a particle is given by T vector, where T means torque, equal to R vector cross F vector. Then R is the position vectors of the position vector of R, where R is the radius, where F vector is the force. The torque is called the rotational force. The torque is also called a rotational force. This a rotational force is, this point is A, that is about the point, and R be the radius, R be the radius. It passes through the point is this one, it passes through the point, this one, acting on a force is, that is F vector is acting on a force. There is a perpendicular line is, this perpendicular line is R vector, that is a tau or T equal to R vector cross F vector, that is a rotational force. Rotational force, for example, a fan, and that is a bolt nut using a spanner. That is a rotation. That is a rotation is, that is a initial point, and the force is acting on a force, that is a radius R vector, acting on a force, that is a rotational force is called a torque. That is a rotational force is a torque. That is R be the radius is the about the point, and passing through the point is A, and B be the R. That is R equal to, R vector equal to through minus above, passing through the point, through minus, through the point through the point minus about the point. Through the point minus about the point is R value. Find the R is a radius, the radius is about the point and through the point. R vector, you now find R vector equal to through minus about is find the R vector. That is the moment of torque T equal to T vector is R vector cross F vector, where F is the force and R vector is through minus about. That is the moment or torque. The result is T vector equal to R vector cross F vector. Now, moment or torque using exercise problem based on exercise problem, question number 13. Question number 13. Find the magnitude and direction cosines of the torque represented by 3i plus 4j minus 5k vector about the point with the position vector is 2i minus 3j plus 4k. About the point acting through a point with the position vector is 4i plus 2j minus 3k is through the point, passing through the point. Given the force is 3i plus 4j minus 5k, given the force, now find the moment or torque. That is torque equal to T vector equal to R vector cross F vector is, now find the torque. Given the force F vector equal to, this is a force F vector equal to 3i vector plus 4j vector minus 5k vector is force. The next one, now find the R. R is through minus about. R vector equal to, given the position vector is through minus about, or the point is A and B. Through minus about is, the position vector is the first one given. That is the point is OA vector. OA vector equal to 2i vector minus 3j vector plus 4k vector. This OA be the position vector. And next one, the position vector is OB vector equal to, OB is 4i plus 2j vector minus 3k vector. Is the position vector B vector. Now find the R vector is through minus about, passing through the point and about the point of the torque. Now find the through minus about, passing through the point is 4i. OB minus R vector is OB minus OA. Passing through the point and about the point. Passing through and about the point, OB minus OA. OB minus OA is 4 minus 2. 4 minus 2 is 2i vector. 2 minus half minus plus 3. 2 plus 3. 2 plus 3 is 5i. 5j vector. Next one, minus 3 minus half plus minus 3 minus 4 is minus 7k vector. Minus 7k vector is R vector. That is R vector. Now find the torque equal to T vector equal to R vector plus F vector. R vector cross F vector. Now find R vector cross F vector. Now find R vector cross F vector. R vector cross F vector is torque. This R vector cross F vector equal to vector product of two vectors. Vector product of two vectors by using determinant form. This determinant form is determinant of first one write in I vector, J vector and K vector. The next one write in a component of R vector. The component of R vector is this one. 2i plus 5j minus 7k is R vector. Now write in the component of R vector is 2, 5 minus 7. 2, 5 minus 7. The next one, the component of F vector. The component of F is 3, 4 minus 5. 3, 4 minus 5. Now expand the determinant. First one write in I vector into getting the minor matrix. 5 into minus 5 minus 25. Minus into next formula is minus 7 4s are 28 minus 28 minus half minus plus 7 4s are 28. Next one minus j vector into minus j vector taking j element, this column and row are eliminated, getting the minor matrix 2 minus 7 3 minus 5. Now multiply minus 5 into 2 minus 10 formula is minus 7 3s are minus 7 into 3 minus 21 minus or minus plus 7 3s are 21 plus k vector into yes k vector into getting the k vector column and row are eliminated, getting the minor matrix. This one 2 4s are 8. Next one minus 5 3s are 15. 5 3s are 15. That is equal minus 25 plus 28. 28 minus 25 3 plus 3 I vector. Next one minus 10 plus 21. 21 minus 10 is plus 11. Already outside minus into plus is minus 11 j vector. 11 j vector. Next one 8 minus 15. 8 minus 15 is that is minus 7 k vector. This one is torque T vector equal to R vector cross F vector equal to 3I minus 11j vector minus 7k vector is moment of torque. Now find the magnitude and the direction cosines of the torque. Find the magnitude. Find the magnitude is modulus of T vector. This is the magnitude. This is a modulus means square root of square the values. That is the square root of square the value equal to 3 square is 9 plus 11 square is 121 plus 7 square is 49. That is equal to root of 121 plus 49, 121 plus 9, 130, 130, 170, 179. Root of 179, that is the magnitude. This is a magnitude or modulus of T vector, that is a magnitude of torque. That is root of 179. Now find the direction cosines. Find the direction cosines equal to direction cosines formula is x by r comma y by r and z by r, where r is magnitude. Where r is the magnitude. That is x, y and z is given the vector. xi vector plus yj vector plus zk vector is the vector form in torque. 3i minus 11j minus 7k. That is the x value is 3, y value minus 11 and z value minus 7. Now find the direction cosine. Direction cosine is x by modulus of t, or x by, where x value is already you know, x value, that is the direction cosine is first one 3 by, getting the magnitude is root of 179 comma y by r, where y value is minus 11 by root of 179 comma, and z value minus 7 by root of 179. That is the magnitude and direction cosines of the torque. Next problem, question number 14. Find the torque of the resultant of the three forces represented by minus 3i vector plus 6j vector minus 3k vector, 4i vector minus 10j vector plus 12k vector, and 4i plus 7j vector acting at the point with the position vector 8i minus 6j minus 4k vector, about the point with the position vector 18i plus 3j vector minus 9k vector. Now find the resultant of torque, given the three forces. One of the force, this one, 2 and the 3 forces given. Now find the resultant force is only one vector, that is only one vector is F vector equal to given, add the 3 forces F1 plus F2 plus F3, getting the resultant force. The next one, now find the R vector. R vector is through the point minus about the point. Acting at the point with the position vector is through the point. About the point with the position vector is 18i plus 3j minus 9k. Given the point, the position vector is first one OA and OB. Now find the R vector is OB through minus about. Through minus about is OA minus OB. Getting the R vector. Next one, now find the torque equal T vector equal to R vector cross F vector. Given the three forces, first one F1 vector equal to F1 is minus 3I vector plus 6J vector minus 3K vector is F1. And the second force is given F2 is 4I vector minus 10J vector plus 12K vector. And the F3 equal to 4I vector plus 7J vector. Now find the resultant force. Resultant force is capital F vector equal to F1 vector plus F2 vector plus F3 vector. That is the resultant force. Add the two forces. First one I vector. 4 plus 4, 8. 8 minus 3. 8 minus 3 is 5. 5I vector. Next one J. 7 plus 6, 13. 7 plus 6, 13 minus 10. 13 minus 10 plus 3. 3J vector. The last one. 12K. 12 minus 3. 12 minus 3. This one is 0 is, sorry, K vector is 0. There is a 0 value. 12 minus 3 is 9. Plus 9K vector is, that is a resultant force. The resultant force is 5I vector plus 3J vector plus 9K vector. Next find R vector. This R vector equal to R vector is through minus about. Given the point is the position vector is OA vector. That is OA vector equal to, now write in reverse to OA vector equal to this one 8I vector minus 6J vector minus 4K vector. And OB vector equal to OB vector is 18I vector plus 3J vector minus 9K vector. Minus 9K vector. Now find R vector. R vector is through minus about. Passing through the point and about the point. Acting at the point, the position vector is passing through the point and about the point is this one. Through minus about is OA minus OB. Through minus about is OA minus OA vector minus OB vector. OA minus OB. 8I minus 18 J vector is minus 10I vector. Minus 10I vector. Minus 6 minus 3. Minus 6 minus 3 minus 9J vector. Next one minus 4 minus half minus plus 9. Minus 4 plus 9 is plus 5K vector. That is R vector. R vector equal to minus 10I vector minus 9J vector plus 5K vector is R vector. Now find torque. Torque equal to R vector cross F vector. R vector cross F vector. Now find R vector cross F vector is vector product of two vector is, that is R vector cross F vector equal to using determinant form I vector, J vector and K vector. And the component of R vector is minus 10 minus 9 plus 5. And the component of F is, already find out the result, force is, the component of F is 539. 539. Now expand the determinant, that is equal I vector into 9 9s are 81 minus 81. 5 3s are 15 minus 15. Minus 15. Next one minus J vector into getting the minor matrix 10 minus 10 5 5 9. Minus 10 into 9 minus 90. 5 5 25 minus 25. Minus 25. Plus K vector into getting the minor matrix minus 10 into 3 minus 30. 9 5s are 45. 9 5s are 45. Minus half minus plus 45. It is equal I vector into minus 81 minus 15 minus 96. Minus 96. Minus 96. Next one minus J vector into minus 90 minus 125 minus 90 minus 25 minus 90 minus 25 is minus 115 minus 115 plus k vector into minus 30 plus 45 minus 30 15 that is equal minus 96 I vector minus into minus plus 115 j vector plus 15 k vector, that is here torque T vector equal to minus 96 I vector plus 115 j vector plus 15 k vector is getting the